first we look into the periodic table. Okay, chemical properties of group 18. Group 18. So group 18 also called noble gases, noble gases or inert gases. They are chemically inert. Okay, so you have to know the word inert means unreactive. Okay, why? Because the outermost shell of the atoms has achieved duplet electron arrangement. Okay, so duplet electron arrangement only for helium. Then the remaining, they are achieving the octet electron arrangement. So octet spelling must be correct. OCTET, not TAT. OCTET. That duplet will be DUPLET. Okay. So this one is the first explanation. I think every year in the SPM will be asking the concept here. Okay, why they? Because they have achieved octet electron arrangement mostly. Then they do not react with other elements. Okay, they do not react with other elements, or the atoms does not lose, gain, or share electrons with others. Okay, with other elements. So that's why these gases that exist as single uncombined atoms. Okay, or also called monoatomic. Mono should be monoatomic gas. Okay, monoatomic gas. Okay, so this is for group 18. So this one is very important. Concept explanation. Here, this slide shows the uses. Okay, just quickly go through. For group 18, helium, it is very light and non-flammable. Okay, so it is used in the filling the weather balloons and airships, and it is used in the thermometer for measuring the low temperature. Okay, so helium also used in the balloons. Okay, balloons. So those balloons filled with hydrogen is very dangerous. Actually, you explode when exposed to the fire. Actually, okay. Then neon, fill the neon bulbs. Okay, for lighting advertisement board. Argon, filling the electrical bulbs. Okay. Then krypton, fill the high-speed photographic flash lamps. Then in the laser to treat the retina of the eye. Radon, treatment of the cancer. Okay, because it is radioactive. So these are the uses for group 18 noble gases. Then next is the group 1. Group 1 also called alkali metals. Okay, alkali metals. So here we look into the electron arrangement. Or the group 1, it has one valence electron. Okay. So when going down the group 1, it is becomes more reactive. Okay. So later we see why it is becomes more reactive. Okay, group 1 alkali metals, they have similar chemical properties. Okay, or same chemical properties. So remember, if the question asks about the same chemical properties, what is the explanation? Because they have same valence electrons. Okay or not? Group 1. So one valence electrons. Okay. Same case if group 17, they have same chemical properties because they have same valence electrons. Is that okay? Next is the reactivity. So here we can see as going down the group 1, the reactivity will increase, becomes more reactive. Okay, or here actually it's called electropositivity. Electropositivity means it able to lose one electrons to form positive ions. okay, or cations. That's why it's called electropositivity. Okay. So why it is becomes more reactive? So first, okay, we can see the electron arrangement. Okay, so when going down the group 1, okay, atomic size increases. Why? Because the electron shells occupied with electrons is increased, right? So this one 3 shells, this one sorry, what 2 shells, 3 shells, 4 shells, 5 shells, and so on, right? When the shells increases, the atomic size will increase also. Okay, then what is the effect on it? The valence electrons is further away. You can see this one, the valence electron is 1, right? So group 1, uh, it tends to lose 1 electrons to achieve or take electron enrichment. So valence electron is further away from the nucleus. Or you can say attraction force between the nucleus and the valence electrons becomes weaker. Okay, attraction force is weaker. Then what is the effect? Valence electrons is more easily to release and then to achieve the octet electron arrangement. Okay, so that's why lithium compared to sodium, this one easier to release because attraction force is weaker. Then potassium more reactive than sodium and lithium because the attraction force is weaker compared to sodium and lithium. Okay, clear? So these two explanation actually is the same for group 17. Only the last explanation is different a bit. So hopefully coming exam on Monday, this at least one of these group 1 or group 17 will come up. Then you know how to answer the question. Okay, again you can see group 17 is called halogens. Halogens. Okay, chemical properties, they have same chemical properties. Why? Because they have same valence electrons. That is 7. Okay, but for the reactivity, okay, here when going down the group 17, the reactivity becomes less reactive. Okay, for group 1, you can see for group 1 is becomes more reactive. Okay, but for group 17 becomes less reactive. Is that okay? Then why? Okay, why? Here, reactivity for group 17 also called electronegativity. Okay, so what is that means? This ability to attract 1 electrons, okay, to forms negative ions. Okay, that is the anions. That is why it's electronegativity. Oh, here you can see all has 7 valence electrons. So how to achieve octet? So it tends to gain 1 electron. Oh, gain 1 electrons. Oh, all of this group 17 needs to gain 1 electrons. Oh, okay. Now how to explain the reactivity for group 17? First, same, when going down the group 17, atomic size increases, right? Atomic size increases because the electron shells is getting more. Then number 2, the valence electron is further away from the nucleus, right? Okay, same as group 1 actually. Or the attraction force is weaker, correct? Is weaker. Same as group 1, but only the last explanation is different. Group 1 is lost 1 electrons, but here for group 17, it is gain 1 electrons, right? So it becomes more difficult to attract 1 electrons to achieve an octet electron arrangement. Okay, why? Because the attraction force is weaker, right? So group 17 becomes more difficult to attract 1 electrons when going down the group 17. Is that okay? So this is chemical properties. Okay, next is the period 3. Okay, period 3 under the syllabus here. Okay, so period 3 You can see all from sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, and then last one is argon. Okay, then sodium, magnesium, and aluminum, they are metal, metal. Okay, then silicon is a metalloid. Metalloid means is semi-metal. Okay, then from phosphorus to argon, they are non-metals. Okay, now class. The more important question is this. Okay, the atomic radius decreases, meaning that uh, sodium has the bigger atomic size compared to the magnesium and so on. Is the biggest. The smallest atomic size would be the argon or argon. Is that okay? So the atomic radius decreases. So why? Okay, why? So okay, this is the explanation. Atomic size decrease going across the period from left to right. Because number one, the proton number increased by one. Okay, each one. Here, proton number increase. Okay, when going across the period 3. Then attraction force between the nucleus and the electron is stronger. Okay, then you will pull the electrons closer to the nucleus, so the size will be smaller. Okay, all the period 3 they have 3 shells, 3 electron shells occupied with electrons. 3 shells occupied with electrons. So, but the proton is more. Okay, then attraction force is stronger. Then the size will be, atomic size will be decreased. Okay, then another one is the properties of the oxide here. Oxide here means this one, when you combine with oxygen, sodium oxide, magnesium oxide, aluminum oxide, silicon oxide, okay, and so on. Okay, so properties, okay, sodium, magnesium, it forms a basic oxide. Basic oxide meaning that these two, basic oxide means it will show that as properties of base or basic or alkali. So how do you know that? Okay, it can react with acid. Okay, it can react with acid. So when you react with acid, then you will produce the products. Okay, then okay, this one very special one, and then the question also always ask here. That is the aluminium oxide. Aluminium oxide, Al2O3. Okay, this one is the special one. It forms the amphoteric oxide. Okay, what is mean by amphoteric? Amphoteric spelling, okay, or must be remember amphoteric. Okay, amphoteric. Okay, what does that mean? It has acidic and basic properties, both. Okay, and it has acidic and basic properties, meaning that it can react with acid, it can react with alkali. Okay, then silicon, phosphorus, sulfur, and chlorine. Okay, they will form the acidic oxide. Okay, acidic oxide. Okay, so meaning that when you react with alkali, okay, for example, sodium hydroxide, then it can react. Okay, and so this is a important point that you need to know. But basically, you need to know this amphoteric. Amphoteric. That is the aluminum group 13. Group 13. Okay. And now next one is the special properties of transition elements. Okay. Special properties of transition elements. Transition elements, they are from where? Which group? Okay, it is from group 3 until group 12. Okay, group 3 until group 12. They are metals. Huh? Okay. So first special properties. They have different oxidation number. Different oxidation number. For example, copper. Copper 1, copper 2. Okay, this one positive 1, this one positive 2. Iron 2, then iron 3. So their oxidation number is different. Okay. Number 2 is they can form a colored ion or colored compounds. For example, copper 2. So they are color. Iron 2, iron 3, brown. Iron 2 is green, for example. Okay. Number 3, they have catalytic property. Becomes a catalyst as a catalyst. For example, iron in the Haber process. Vanadium dioxide in the contact process, for example. Okay, number 4, they can form complex ions. Okay, complex ions means not the simple ions like this. They can form the like tetra amine copper 2. Okay, like this is a complex ions. Got it? So normally this part will come out in the um, objective questions. Objective questions. So hopefully it come out again. Okay. Now, okay, we look into the comparison of ionic and covalent compounds. Okay. Ionic compounds, remember, yesterday we talked also on this. It is metal with nonmetals. Okay. So with nonmetals. Okay. So, okay, for example, I give one example here, sodium chloride, okay, sodium chloride. So, covalent compound, for example, is a this one is a methane, for example. Okay, for ionic compound, it has higher melting point and boiling points. This one, covalent compound, it has lower. Okay, then this one you need to know how to explain. Why it has higher melting and boiling point? So we focus to the bond. Of course, it has strong electrostatic force between the ions. So more heat energy needed to overcome the force. Is that okay? Then covalent compound. Okay, here it has weak intermolecular force or van der Waals force. Here, don't mention about the covalent bond. We are not going to mention about covalent bonds. Okay, so this one is weaker. Then less heat energy is needed to overcome the weak force here. Okay. Next is the electrical conductivity. It can conduct electricity in the molten and the aqueous solution for ionic compound. Why? A very simple one. It has freely moving ions. Okay. So remember, when we talk about the electrical conductivity, you will focus to the freely moving ions. Okay. In the solid state cannot because cannot conduct electricity solid. Why? Because it has no freely moving ions. Okay, for covalent compound, it does not conduct electricity in any state because it consists of molecules only, no freely moving ions. Therefore, covalent ionic compound soluble in water. insoluble in organic solvents. But covalent compound is reverse, insoluble in water but soluble in organic solvent. So remember, if in the essay or structure question asks you to give comparison, okay, on the physical properties, physical properties, or you can choose any two of these. You need to know how to explain, do the comparison. Normally, we'll choose melting point, boiling point, and can conduct electricity or not. Okay, very, very popular questions here. Okay, very simple, but students always forget what to write. Okay, next under electrolysis. Okay, so any chemical substance, it can be divided into electrolytes and non-electrolytes. Okay, so now we look into what is the meaning of electrolytes. It's a substance that can conduct electricity when they are in the molten or aqueous state, and it undergoes a chemical change. Okay. Non-electrolyte, the reverse one, cannot conduct electricity, no matter what state it is. Okay. So example for electrolytes, okay, ionic substance, for example, acid, any acid, dilute. If you see the solution for acid or alkali solutions or molten salts, so okay, then or salt solution, okay. Covalent substance under non-electrolyte like naphthalene, sugar solution, latex, hydrogen chloride in organic solvent. So hydrogen chloride in organic solvents meaning that it has no hydrogen ions. If here in the water, then it becomes the electrolytes already. Okay, next. Now we can see in the solid state, this one actually is the electrical conductivity. Okay, it's the physical properties just now we mentioned already. Okay, so in a solid state, ionic compounds do not conduct electricity. Okay, because what? Because the ions do not move freely. They are in the fixed position because of the strong electrostatic force. Okay, but in the molten or the aqueous solution state, then it can conduct electricity because it has freely moving ions. Okay, next is under acid. Acid. Okay, thank you. So more in the acid. Okay, so acid, we have two important terms. One is the monoprotic acid. Another one is diprotic acid. So mono means one, di means two. So what is the meaning of monoprotic acid? There's a monoprotic acid produce one mole of hydrogen ions when ionized in water. For example, here, hydrogen chloride, when ionized in water, produce one mole of hydrogen ions. Okay, for example, here, hydrochloric acid, nitric acid. Okay, then diprotic acid, important one is the sulfuric acid now. When ionized in water, it produces 2 moles of hydrogen ions. It produces 2. 1, 2. Is that okay? So this is the diprotic acid. Okay. In SPM level, for strong acid, we will focus to these three on here: hydrochloric acid, nitric acid, and sulfuric acid. Only these three strong acid. Other than these three, all are weak acid. Okay, then diprotic acid, if same concentration, let's say this one is 1 mole per cubic decimeter, then it produces 1 mole of hydrogen ions, right? So meaning that this one will be 1 mole per cubic decimeter also. Okay? But for sulfuric acid, this one is 1 mole per cubic decimeter. When ionized in water, it will be double, 2 moles of hydrogen ions, meaning that this one becomes 2. That's why when it comes to the rate of reaction, a diprotic acid, it can react faster. Okay, react faster because of the concentration will be double already. Okay, so it will be has a higher rate of reaction compared to monoprotic acid. Okay, then in the acid, okay, you have to remember one important concept here is the role of the water in showing the properties of acid or alkali. Okay, so for acid or alkali, it cannot cannot shows the acidic properties in the organic solvent. Okay, organic solvent or pure acid cannot. How do you know it's pure? For example, like you will see this word glacial. Glacial means pure or dry. Okay. Then another one is ethanol acid in the organic solvent like propanol. This one no water, so it cannot show the acidic properties. Okay. Then for alkali, also the same. It cannot show the alkaline properties. Okay. But in the water, if got the water, then it can ionize already. It shows the hydrogen ions or hydrosonium ions, hydrogen ions or H3O plus. This one is the hydrosonium ions. So only with the presence of water, they can show the properties of acid or alkali. Okay. So that's why sometime in the exam got a table like this. Okay, let's say let's say HCl. Okay, in solvent A, then solvent B. Okay, like this, right? So hydrochloric acid in solvent A cannot cannot react. In solvent B can. Okay, so this one only. Okay, so once hydrochloric acid in solvent A cannot show the acidic properties, but in solvent B can. So you directly know in solvent A, the one can show the properties. So directly we know this one is the water. Okay, water must be present so that it can show the acidic properties. Then solvent A will be organic solvent. For example, okay, give an example like propanol. Okay, so this is how you determine the solvent A and B. Very easy concept actually. Is the role of water. Acid or alkali, must have the water, then they can only show the acidic or alkaline properties. Okay. Okay. Next is the strength of the acid or alkali. Okay. So here is pH. 7 is neutral. 7 is neutral. Less than 7, like say 6.99 is considered acidic. Then when pH less than 7, more to 0 becomes a more acidic. Okay, lower pH, strong acid. Higher pH, less than 7 will be weak acid. Okay, now how to define the strong acid? Okay, it ionizes completely in water, produce high concentration of hydrogen ions. Okay, just now I mentioned to you already, hydrochloric acid, nitric acid, sulfuric acid. Okay, for weak acid, ionize, okay, the word here, remember, partially in water, produce low concentration of hydrogen ions. Example, ethanoic acid. Oh, okay. Then for alkali, more than 7, 7.1 is considered 7.01 considered alkaline already. Okay, more to 14 is more alkaline, strong alkaline. So higher pH. Okay, then the definition are the same. Ionize completely in water, high concentration of hydroxide ions. For acid is hydrogen ions. For alkali will be hydroxide ions. For example, these two: sodium hydroxide, potassium hydroxide. Only two example of strong alkali in SPM level. Then for weak alkali, ionize partially in water, produce low concentration of hydroxide ions. Example, ammonia or ammonia and NH3. Okay. And next is the rate of reaction. Okay. So this one confirm will come out. We don't know which factor, but we learn only 4 factors normally will be asked. So let's say effect of concentration. Okay, how do you know it's concentration factor? You go look for the concentration. How do you know it's the concentration here? The unit here, mole per cubic decimeter. This unit is for concentration. Okay. Volume, it won't affect. So don't don't interfere by the volume. So this one is 0.8. So 1 and 2. So experiment 2, higher rate of reaction. So explain based on the collision theory, right? Okay, so you need to mention first, at least you can know this rate of reaction in the experiment 2 is higher. When we talk about the rate, we use the higher or lower. Okay, don't use faster. Don't use faster. Wrong. Huh? Okay, how to explain using the collision theory? Then we mention the concentration of acid in experiment 2 is higher. Okay, then the number of hydrogen ions per unit volume, the rate words are important one. Then after that, frequency of collisions between what? Hydrogen ions from the acid. Oh, sorry, this one is wrong. Not carbonate ions. This one is wrong. So this should be calcium carbonate. Okay, calcium carbonate. Okay, calcium carbonate. Okay, increases. Then frequency of effective collision between hydrogen ions and calcium carbonate, not carbonate ions, sorry. Calcium carbonate increase. Okay. So this point and this point, it has the difference of this word only. One is effective collisions, another one is collision only. Oh, so rate of reaction is increased. So this one is for the concentration factor. Then size. Okay, how do you know the size? Okay, you will see the word like powder. Another one is like granulated. okay, or you can differentiate, okay. The powder one will be smaller size, okay. So we know that experiment 2 has higher rate of reaction than experiment 1, okay, because use the powder, right? So experiment 2 has a larger total surface area because smaller size, right? So bigger total surface area. Oh, total surface area, don't forget, don't just write surface area. Then frequency of collisions between, okay, acid, yeah, acid always hydrogen ion, the particles, and then zinc is a zinc atoms, okay. Uh, so you need to mention about the atoms here, need to mention the ions, okay. Don't write particles. If particles, then this point no mark. Then after that, frequency of effective collision. You see again the difference. Okay. Next will be temperature. Okay, so here you will see one is 40, one is 50. So experiment 2, higher rate of reaction, higher temperature. So kinetic energy of hydrogen ion and thiosulfate ions increases. So kinetic energy. Then hydrogen ions and thiosulfate ions move faster. Then frequency of collisions between the hydrogen ions and thiosulfate ions increases. Okay, this one is using the sodium thiosulfate and the sulfuric acid. Hydrochloric acid also the same. The effective collision increases, then higher rate of reaction. Okay. So when we talk about the temperature, you need to mention about the kinetic energy. Okay, next finally is the catalyst. How do you know it's the catalyst? You will see what? You see two conditions are the same, but suddenly it will exist or appear extra chemicals. Okay, extra chemicals. So you will know it is the catalyst already. So rate of reaction in experiment 2 is higher. Why? Because the presence of catalyst. So catalyst will lowers the activation energy. Okay, lower activation energy. So more collisions between the zinc atoms and hydrogen ions. Okay, uh, able to achieve the lower activation energy. The frequency of effective collisions between the hydrogen ions and zinc atoms increases. Then rate of reaction will be higher. Okay. Next is the thermochemistry. Okay, thermochemistry. Uh, two. One is exo, one is endo. For exothermic chemical reaction that give out or release heat to the surrounding. Okay. Temperature of the surrounding increases. Okay, so you will see thermometer reading will go up, increase. Okay. For endothermic, okay, absorb heat from the surrounding. So the thermometer reading will decrease. Okay, very easy to recognize. And then another one is delta H. This one is positive. This one delta H is negative. Okay, so you will see. Okay, this one is energy level diagrams. Okay, energy level diagrams for exothermic and endothermic. Okay, so just like I mentioned to you already, negative and positive. Okay, so I think that's all I need to revise with you. Okay, and wish all the best to you.